There are two ways to build a schedule method. The first is predictive scheduling and the second is refined scheduling. So let's cover refined scheduling first. Here I have opened a pinpoint file which has some peptides, proteins and transitions that we're monitoring. Here are the raw files that monitor those transitions, and here's the data analysis. It has the retention times, the peak areas. For example, this particular peptide was identified at 12.05 minutes and this peptide identified at 13.57 minutes, and so on and so forth. So these transitions and everything were monitored for the entire chromatogram. As in the first method that we ran was unscheduled. Now when we come to method refine and optimize, this is the section that can build an empirical schedule method. So as you can see, there's a option that says green peptides, keep all or unselect all. So this will take out all the green peptides in our next run, and this will keep all the green peptides. This option will take out all the yellow peptides, and checking it back in will bring in will keep our yellow peptides in the next iteration. Along with keeping the yellow or green, we can also define the scheduling window size. So for example, this peptide was identified at 13.11 minutes and it's a green colored peptide. We can say in the next iteration make a window of 0.5 minutes around that, plus minus 0.5 minutes around that. So in the next iteration, this peptide would be monitored only from 12.6 to 13.6 minutes if we have given a window of plus minus 0.5. We are opting to filter out the red peptides because these didn't work in our first run, our first iteration, but if we want we can keep them further and either schedule them little wider. If we already had scheduling in the first iteration, we can make them a little wider, or go and schedule them for the entire run, let's say 0 to 30 minutes. We can select that option as well. So these are a bunch of options that can help us generate a schedule method in our next iteration. So we'll keep our green, keep our yellow, but take out our red colored peptides, and we'll select generate next iteration. For our next method file, we'll get a message saying that all the information will be overwritten version 2. If you go to raw file management, you'll see there's no raw files. Everything has been taken out. That's in the version 1 file. So that's how we can build our refined scheduling. Now to go over predictive scheduling, I'll open the same file. This file, notice that this file has some red peptides and black colored peptides. So there is a library entry that we used to generate transitions and everything. And along with that, we also have a library, retention time that has been identified for every single peptide. So this peptide was seen at 44 minutes in our discovery gradient. This peptide was seen at 46 minutes in our discovery gradient. So that has been brought in because we added a proteome discover file. And here are the raw files, and here's the data analysis, which has the retention times and the peak areas. So this peptide identified at 12.05 minutes. The second option to build scheduling is predictive scheduling, and for that we need to train pinpoint on matching our discovery and targeted quant gradients. So if we come to method refinement, you'll see this graph show up with x-axis as library retention time and y-axis as retention time on the triple quad gradient. Now depending on how similar you have the columns and the buffers, it's going to be variable as to how tight this curve looks, how linear this looks. But in our case, it looks very linear. In fact, we can see this peptide just by clicking here and going down further, clicking another peptide as to where it lies in this gradient. So we can choose to ignore this peptide. We can say do not use it if we think it's quite far away from the gradient, or it's a modified peptide, or we can choose to keep this out or keep this in. Let's keep this in. And based on this linearity curve, it has figured out the slope and intercept. So now if we want, we can train pinpoint and just say save retention time prediction settings. And what that will do is, whenever we bring in a new peptide which has a library retention time identified, so if you bring in another peptide which is, let's say, identified at 42 minutes, in that case the predictive time that a pinpoint will build is approximately 12.75 with 42 minutes retention time on the library. And then we can say make it plus minus 2 minutes around that, or maybe plus minus 1 minute around that. So depending on what the error we think is on our linear curve, we can decide that how big a window do we want. But if you're happy with the slope, this intercept, and a plus minus 1 minute window, we can say save retention time prediction settings,